Hi guys, welcome back to my channel. So we have been using LLMs for quite a while now to generate code, generate applications for ourselves, and we have saw many frameworks. You see, we have used RAG with various models. We have used BBAGI, Agent GPT, Auto GPT, if you know the good old days. Then we used Devin as well, the Devin. And after that, we have seen many other frameworks which have performed very nice in the SWE Bench. So SWE Bench is, just as the name says, software engineer bench, which evaluates the performance of any framework or model so as to how it performs in real world coding tasks and GitHub issues. So you have seen the score has been below 20 and nearly same after Devin. We have seen some growth, but it's not that good. But today we are going to see Cosign. And before I say anything, just look at its score. You can see it's 30.08%. Absolutely ginormous compared to its competition. So as they say, it is the world's best AI software engineer according to them, and it has 30% eval score, that is evaluation score. Now there is an introduction video about Genie from Cosign. So this model is Genie. Let's see what the founder has to say, and then we'll get back to this whole web page.
Genie has the highest score in the world on the SWE. It's not the. Why are you saying the? Hi, I'm Ali, co-founder and CEO of Cosign, a human reasoning lab. And I'd like to show you Genie, our state-of-the-art, fully autonomous software engineering colleague. Genie has the highest score on SWE Bench in the world. And the way we achieved this was by taking a completely different approach. We believe that if you want a model to behave like a software engineer, it has to be shown how a human software engineer works. We've designed new techniques to derive human reasoning from real examples of software engineers doing their jobs. Our data represents perfect information lineage, incremental knowledge discovery, and step-by-step decision making, representing everything a human engineer does logically. By actually training Genie on this unique dataset, rather than simply prompting base models, which is what everyone else is doing, we've seen that we're no longer simply generating random code until some works. It's tackling problems like a human. So let's take a look at Genie solving a real problem from a real repo. You'll notice you can prompt Genie with a natural language prompt, ticket, or in our case, a GitHub issue. So I'll go ahead and start. So now Genie's fetched the GitHub issue. When I click solve, it'll start looking into the problem. As you can see, it started thinking about what it'll need to find in order to solve this problem. This process is iterative, and it will keep going until the model is satisfied that it's found everything that it needs. There we go. We can see that it's pulled a couple of examples of files from the codebase that intuitively look like they're relevant to the issue that we're looking at. Now it's going to start writing code to try to solve the problem. Much like the retrieval step, this process is also iterative. Genie will write code, run it, and then react as a function of what it's seen. One of the great advantages of our data-first approach is that because our model has watched more humans solve problems than any human could in a lifetime, it has a great grasp of how software engineers really break down and triage issues. It's also easily able to edit code in place, which is something that foundational models struggle with without rewriting entire sections. Genie is now running the code it's writing and is using the debugging tools that we've given it to look at application state and execution flow, just like a developer would. Again, it's seen humans do this millions of times and is emulating that process. So back to the task. We've just watched Genie try a couple of different approaches to solving this problem, and at first it wasn't successful. So it planned again and has just written an alternative approach. This process can continue indefinitely, and because of the long context window that Genie has available to it, many different approaches can be tried without losing any information along the way. There we go. All the tests are now passing. Genie has successfully solved this problem, and it solved it in just 84 seconds, which I'd guess was much faster than any human could come to an unknown repo with an unknown issue and solve a problem. So now it'll write a PR title and a body and actually open the PR on our linked GitHub repo through the Cosign web platform. Any comments or reviews left on that PR will be heard by Genie and will be acted upon as if it was a real human colleague. We'd like to thank OpenAI for allowing us to fine-tune such a long context window model, and I'm extremely excited to see where and how you guys use Genie. If you'd like to give Genie a try, just head over to our website at cosign.sh. We truly believe that software engineering is just the starting point, and that we can codify human reasoning for any job or industry. We can't wait to show you what we've been working on.
And you wouldn't believe it, I walked in here and I said, wow, what an amazing reasoning engine.
So that was about Genie from Cosign, from the founder himself. And so some of the few key points that I have noticed in this model and this video is that first, they are not using a base model that other platforms are using, like if you know Devin or Devik or anything like that. Under the hood they have the same models that we use regularly, but they have a custom fine-tuned model from OpenAI which has very long context. I think they might be referring to the Gpt4-O long output that has 64k context length. If you haven't seen my take on that model, it will be visible in the I section, or I will be linking that video in the description. So it is a custom model which has 64k context as output. So I think they might be using that or any other fine-tuned model from OpenAI, and even they have again trained it on a custom training data that they have acquired, and the result is something which we are seeing over here. So one more thing that I saw from the video is that it is able to answer users query when it comes to GitHub issues, and respond to any doubts that users may have in GitHub related to the issue which the Genie model has resolved. So even in this website we see a demo of it, so just have a look. At the start, if you can see here, they have given it a prompt: create a new page under the website folder announcing our new model. So the model has been prompted over here, and what happens next is it uses powerful tools. So it seamlessly integrates with your code base and external sources. It does file search, folder search, internet search. It can execute Git commands. That is how it it is able to publish the solutions to the issue directly to the GitHub repo. So now if we move on, the first step is precise file identification. So as you can see, it is identifying the relevant files that are needed to be changed in the code base to solve the particular issue. As it is mentioned here, narrowing down the essential files and documentations quickly, Genie streamlines the initial phase of problem solving. So when you have selected the correct files, you can develop an effective and efficient solution. So the first step is precise file identification. So as you can see here, it has found out the model page, scroll section, nav bar, and all of it. Now it starts planning. Here you can see the planning has started. You can see it uses advanced drag and tool selection. So let me just show the whole code. Here you can see it is planning. It is seeing the model page and it is ensuring that it is visually engaging and aligns with the brand's aesthetics. Then it uses the scroll section.tcx to create interactive and dynamic sections for the state of the model page. Now it modifies the navbar.tcx to include the link for the page that it is creating. So it is planning what it should be doing. The next is in-place edits. So it doesn't do unnecessary writes. It doesn't write the complete code. It makes in-place edits, which is very important when it comes to cost and being economical. So now is agentic validation. So after it has generated the code, it is testing. You can see home page loads correctly. Navbar let me roll it again. You can see home page loads perfectly. Navbar links functionality, page render, model page, scroll section, cosine gradient, and it is testing all the edits which it has done, all the pages and all the possible errors that could happen in the website. So this is what makes it different, and I think it is very promising. So I would first suggest you to join the waitlist so that if they give a wider release, then you and I are able to use it. And that brings me to the final verdict, is that it is good, but what should happen is that it should be eventually given to a wider audience so that people could actually use it for themselves. Unlike Devin, I mean, like, we had its demo and after that we don't see anything significant from them. So it is very promising, especially the score is, I think, nearly double of Devin. I think more than double of Devin. So One more thing I wanted to tell is that we also know about how they come up with this benchmark. So they sometimes purposefully select issues that are not very hard and they reach out to this analysis. So it could be many things like that, but when this model or when this framework is released in wild, only then we can make a verdict on this model. So what you guys think about this model, and if you had access, what would you generate first? Tell me down in the comment section below. Thank you guys for watching.